All right, so what we're gonna do is we're gonna go to so at first we're gonna go to QuickTime. Sorry, I have so many things going on here. Taylor series, Taylor polynomial. Okay. So what we're gonna do is we're gonna take e to the x. This is the function e to the x.
Can you X out of that?
Yeah. And if I take e to the x, this is a basic function. It looks like this. The function is gonna be a e to the x like this. This is e to the x. What happens if I take a derivative of x? Derivative of x is e to the x, right? And we plug in 0. So that is going to be e to the 0, which is 1. Which is, that's going to give you y equal to, equation tangent line, it'll be y equal to x plus 1. So this is the tangent line. So this is called a first degree approximation. We approximate at a first degree. So which point is accurate? You look at this point, is the accurate point. But anything else, like the more further I go, the less accurate it is, right? So you see that distance here is getting further and further and further and further apart. But in a small calculation, let's say 0.1, it's very, very fair. It's good approximation. It's actually, it can be a lot better, but you can impose the so here we can like pretend that you can take a derivative again. What's derivative again? F double prime, right? E to the x. And if you plug in 1, that's going to give you 1, right? So kind of think about, I think the way kind of think about it is like if I were to take, like if I take an integration of this, if I take an integration of this one, it's going to give you x squared over 2 plus x plus c, right? And then we can figure out what a c is by plugging 0, and c is more likely to be 1. So here we can do a second approximation. The second approximation will be 1 plus x plus 1/2 of x squared. So this is a p1 of x. So p1 of x.
How did you get that?
Okay. Pretend I take integration of it and plug in 0 and plug in 1. I'll plug in 0 and you get 1. And you got a c. That's how you get that. Okay. So then you say, what does that look like? Well, you can do another integration. What's the integration of this one? 16x cubed. X cubed over 6, right? Yeah. And this one is going to be what? X squared over 2, right? Plus x, right? And then plus 1, right? So eventually it's going to look like this. I mean, I can write it forward if I... Doesn't matter. There's no... I writing this way is because I can hopefully come into the pattern. So what do you think the pattern is going to be?
the extra term gets bigger.
X to the what?
X to the n over. Yeah, over factorial.
M factorial. So that means this e to the x can be right like this all the way to infinity. The more, the better. The more iteration, that gets better. Okay, the more iteration, that gets better. So I will show you in terms of graphing. The graphing is, this one is actually here. This one is e to the x, right? And this is 1 plus x. Do you see that? And if I change to another approximation, if I add extra per approximation, it's going to look like this. Do you see that? It's much more accurate than 1 plus x. But after that, it's not accurate anymore. But it has more range now. More domain is going to be similar. So the more iteration goes, if I look at this one, better than before, yes.
Is that like where you do like the sine graph and it like goes that way and then it like starts like.
Yes. And we're going to get there tomorrow. But here we're going to start with the e to the x. Yeah. And if I go with more, guess what? Very accurate all the way to -1. If I go more, it's going to be very accurate all the way to even close to -2. Now, what if we do it to 2,000 times? Right? If I do it to 2,000 times, that means x to the 2,000 over 2,000 factorial. That means you add up every single term like that, you're going to get this. It's going to get from here to all the way to infinite. But after that, they have problem rendering the rest of the number. Because if you start with, let's just say start with, here's 5, right? So we're going to start with, we start with a 5. 5 is going to look, 5 is going to look like this. Sorry, let me do 5. 5 is going to look like this. 50 is going to look like all the way to here. But at the 20, it spike up. Okay. So they can be all the way accurate to all the way to e to the is e to the -20. And you can do another one, 500. Then it's pretty much, you don't see any spiking up anymore. Maybe later. But you see that calculator have problem rendering those numbers now. You see that they are kind of slow to generate those rest of the number. But as the more it goes, the more accurate it goes. Okay. Now, here's the part that it may confuse you. It may not. So we're going to start with try to do a approximation. So we're going to do approximation with the f of x is e to the x. And we know this approximation is going to be something like this. It's going to be like something a to the 0 plus a1 times x minus c. Don't worry about what x minus c is, because usually we're going to assume that c is equal to 0. Plus a2 to the x minus c to the 2 plus a3 to the x minus c to the 3rd plus dot 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 all the way to an times x minus c to the n. So this is like a polynomial. So we're going to assume c is equal to 0. If c is equal to 0, it'll be x to the n. Is this okay? So this is some type of polynomial. We have a0, a1, a2, a3. But the thing I'm really care about is this an. That's the things I'm care about. So the problem is, how do I get to the an myself? Well, the idea is, let's take a derivative. So what happens if you take a derivative of this? Let's just say Pn to the prime of x. Now, like I say, this part you don't need to worry about it. If you don't understand it, you don't need to worry about it. But see if you can understand it. I never bothered to try to explain it before, but I'm trying right now, see if it works. If it doesn't work, it doesn't work. So let's take a derivative of a to the 0. What's derivative of a to the 0? 0. See, you guys are pretty good. You guys are genius, right? What's derivative of a1 times x minus c? Just a1. What's the derivative of a2 times x minus c to the square? 2 times a2 times x minus c. Very, very good. Plus 3a3 of x minus c to the second. Plus dot 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 to n a to the n of x minus c to the n minus 1. Because I'm going to have to subtract 1. The n is going to be dropped down. Is this too fast? Okay, let's take another derivative. This one's 0. And this is 0 again. Now this one is going to be plus what? What is it? 2a2, good. And then plus what? 3 times 2 times a to the 3 times x minus c to the 1, right? And plus dot 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 to what? Well, eventually it's n factorial, but right now it's going to be n times m minus 1 n times a to the n times x minus c to the n minus 2. P to the 3, you're going to see the pattern. By the third derivative, this is all 0 plus 0 plus 0. And this is going to be 3 times 2 times 2 times 1, a to the 3. Is that okay?
Is that 3 times 2 times 1?
Yeah, 3 times 2 times 1. Yeah. Which is, we know that it's going to get to 6a3. And plus n times m minus 1 times m minus 2. And times a n to the x minus c to the n minus 3. So ideally, if I were to take the nth derivative, so we're going to go to the nth derivative, right? Pretty much all this will go to what? 0, right? So we go to 0. So then, what do you have left? What do you have left? N factorial times a to the n. Good. What we just figured out is a to the n. If I solve for a to the n, just like what we said, this one's going to be p to the nx divided by n factorial. Okay, so yes, I agree with you. You're going to take a nap, but I need you to stay awake. So this becomes, there was 2 types of series. This one, it turned into Taylor series or Maclaurin series. So I'm going to show you, the only thing that you really need to know is this. P n of x is equal to f of 0. We assume that c is equal to 0. Plus f prime of c times x, just like what we're doing, because this is over n factorial, this is over 1 factorial, right? Plus f2 of c of x squared over 2 factorial. Does that look familiar? 2 factorial x to the that And plus f of 3 of 0 to the 3 factorial times x to the third. Yeah, f to the third. This is 0. Okay, so now I'm gonna plus f. It's gonna be dot 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 to the f n of 0 to the n factorial times x to the n. So this is called Taylor-Maclaurin, Taylor series. Is this okay? In this case, we're gonna use 0 as a center. 0 as a center is very important because we're using this particular point right here. We're using 0 as a center. So this is known as a Maclaurin polynomial. Taylor is gonna be this. Okay, so the Taylor is gonna be P n of x is equal to f of c plus f prime of c of x minus c. There was a c there, there's a shift, plus f double prime of c over 2 factorial times x minus c to the second, plus f n of c over n factorial times x minus c to the n. Now this is the most important thing. This is the most important thing. We can try with e to the x, and we can try with the cosine of x. Okay, start with e to the x. We already got e to the x before. I'm going to show you. This is how you using the Maclaurin series. So using Maclaurin series, we just have to do f of x equal to e to the x, f prime of x equal to e to the x, f double prime of x equal to e to the x, f of third prime of x equal to e to the x, and f n of x is equal to e to the x. Now what happens if you plug in 1? You get what? Oh, if you plug in 0, what you get? 1. F double prime of 0. F is also 1, right? Is equal to 1. So all we're gonna do is plug in this. So now we're gonna plug in c, right? And c in this case, sorry, we're gonna use the Maclaurin series. What's the f of 0? 1, right? Plus f prime of 0 is what? 1x to the 1 factorial plus 1x2 over 2 factorial plus 3 over 1 times x to the 3 over 3 factorial. Do you see that? And that's your Taylor series, x4 over 4 factorial, dot, 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 dot. And that's how you come to the term of e to the x. Yes?
So you use Maclaurin to get the Taylor series?
No. Taylor series, the difference between Taylor series, this is Taylor series, sorry. This is a Taylor series. The only difference Taylor series is there's a center is at C. But Maclaurin is a center at 0, makes a lot of things a lot easier. Okay, so now you're gonna say, well, what does that all mean? This means that I can take this is was supposed to be your homework, but you can do it to the sine and cosine. And so let's just say if I have today is p of x, or let's just say f of x is equal to cosine of x. I want you to figure out the first 4 term. And then after I want you to figure out the first 4 term, I want you to figure out an infinite term. Okay? So what do we have to do first?
F prime of x.
Yeah, you have to do all that. F of x, prime of x, double prime of x, triple prime of x, 4 of x. You can do one more.
How many should we go? You go to 5?
5 will be good, but 4 is good enough. Yes,
How do we know what to plug in? Do we always just assume 0?
we'll plug in 0 for now. What's f prime of x is equal to?
No, Mr. A.
I know, first time I get Bennett. Oh wow. I'm trying to hit the forehead too. Okay. So if I take a derivative, what am I gonna get? Negative sine of x, good. What should you take a derivative of negative sine of x? Negative cosine of x. I have to take a f triple prime of x. Sine of x. And what's cosine of x, right? And negative sine of x. Okay, so what's the f prime of 0? 0. What's f double prime of 0? Negative 1. What's f triple prime of 0? What's f fourth of x? 0? Is what?
1.
1. Okay, so you do see the alternating, right? You do see this negative 1, you do see this 1. Okay. Are you okay so far?
Yes.
Okay, so what is your first term?
1.
If you had to, oh, we forgot to plug in f of 0 is what? 1. Okay, so be 1. Is that okay? What's the next term? Okay, so what's that? That'll be 0, right? What's the next one? Negative 1 over 2 factorial x squared, right? And what happened to the third term?
Disappears from 0.
Third term is going to be 0. And what happened to the fourth term? 4 factorial to the x to the fourth. And then that's going to keep on going. If I ask you p of 4 of x, that means you stop at the 4th degrees. And can stop there. If I ask you what's p of 6 of x is what? Will be 1 minus x squared over 2 factorial plus 1 over 4 factorial x to the 4th minus what? 1 over 6 factorial x to the 6th, right? And yes, this becomes like this. So can you summarize a series that looks like this? Can you summarize a series that looks like this? So the first term is going to be x, right? Well, the first term is positive. The next term is negative. So what is the first term? We're going to start with summation n equal to 0. And this is infinity. What would it be? X to the what? 2n. Over what? 2n factorial? Good. But your first term is positive. So it'd be negative 1 to the what? N? Is that okay? So now what happened? We're using the Taylor series. We just take the first 4 derivatives. We figure out a pattern. And we write it out. And after that, we summarize a term. Summarize it as series. This series is exactly representation of what? Of cosine of x. Now I'm showing you here because this is kind of important, so that we're gonna show you what a cosine of x look like. So we're gonna change this to cosine of x, and cosine of x looks like this. And we're gonna get rid of this, and we're gonna say summation of n equal to 0. We're gonna start at 1 here first, and we say, what was it? Negative 1 to the n, right? So that's going to be negative 1 to the n. Sorry, that's going to be negative 1 to the n power. Are we okay here? And to x to the which power? 2n. Is that okay? Divided by what? 2n factorial. So we're going to have 2n factorial of factorial. Factorial is right here. And we're going to use this as a maybe c and add a slider for c. Okay. And we're going to do from 1 to maybe 100. Okay. So we're going to let it play.
What? Whoa. Oh my god.
Is that pretty crazy?
It's like the bigger you get, the more like.
Yeah, the more accurate it is, because you're doing a lot of different iteration. The more iteration, the more accurate it's going to be. But this is very satisfying, right? This is like only into 20. Let's just go to 20. You will see that.
It looks like a swing.
You sure I saw that on TikTok?
Huh?
I saw that on TikTok.
Yeah. But can you do it on your own? That's more cool. You can do this. This is very easy.
That's give you a phone.
Yeah. You can make your own TikTok video now.
Go to plus, Mr. J. Go to the plus thing.
Go to what?
Go to the file. Go to the file. The one above the plus.
Yeah.
Scroll down. I think there's a Taylor Swift.
They are. You had to go to example. No.
Pretty sure there is.
Save graph.
Those are your saved ones.
I don't know where I put it.
That's in the example.
On the decimal examples.
Go to the example. Lower, lower, lower. I'm like pretty sure. Yeah, there you go.
Where?
Little up, little up. Calculus tailored.
Yeah. So your homework is do it with sine of x and natural log of x.
Dude, it's right there.
For the power series, yes.
Sign of X,
So we already know e to the x is what? X to the n over n factorial, right? Summation n equal to 0, infinity, right? We already know the cosine of x is what? Negative 1 n to x to 2n over 2n factorial, right? And so that is going to be summation of n equal to 0, infinity. Will be sine of x and will be natural log of x. Yeah, that's your homework. You want to figure out what the sine of x and natural log of x. Natural log of x is the hardest one.
Thank you, Mr. A.
I'll see you mañana.
One to 8 hours. Full note. You can hire a tutor. You can leave the room whenever you want.
Yeah, and this is anything you want. We were not sure.
Sounds like a June.
I literally like, it was like, oh, now I have school order. No. You might like terrible, you know. Yeah, so basically it was like.
Oh, no, we didn't. Yeah, that's all. Oh,
Is it? Oh, I feel like yeah, it is. I didn't go, and then I remember last week they had a couple, but it was the first day of class. Did not go.
Oh, for ln x, I need the center to be at 1. Sin of x, you can do 0. Do you know why ln center has to be at ln 1 is 0, 0, but you cannot do ln of 0. Yeah. So make sure that this ln of x has to be center at 1. So this is the center. Yes.